Welcome to Debug Log, software engineering war stories, architecture decisions, and lessons learned the hard way. Let's dig in.
Okay, so picture this. You've been grinding away trying to implement the perfect clean architecture in your latest project. Layers upon layers, interfaces for everything, dependency inversion, you know the drill. You feel like you're doing everything right.
Right. You've got that smug architect feeling, like you're building a fortress against future technical debt. You're thinking, this is future-proof, baby.
Exactly. And then someone like Derek Comartin comes along, drops a manifesto called Why Clean Code is Killing Your Velocity, and basically calls your entire sacred cow a scam.
And suddenly, that fortress feels less like a bastion of good design and more like a gilded cage, locking you away from actually shipping anything. It's a gut punch, but frankly, it's a gut punch a lot of us needed.
I mean, we've all been there, right? The industry spent years telling us that layering was the answer to everything. We were traumatized by those N-tier architectures that ended up as big balls of mud, where one change in the database broke the UI.
Oh, the trauma was real. I remember one project where we tried to update a stored procedure, and suddenly a completely unrelated part of the app crashed because of some implicit dependency we hadn't even documented. It was like pulling a thread and watching the whole sweater unravel.
So naturally, when guys like Uncle Bob Martin, Jeffrey Palermo, and Alistair Cockburn came along with their concentric layers, onion architecture, hexagonal architecture, it felt like salvation. It gave us a checklist. You put an interface here, a mapper there, a repository for that, and boom, instant architectural responsibility.
That psychological safety is key, isn't it? It felt good to feel like you were doing things the right way. It became almost a dogma. But as Comartin points out, that safety is often an illusion. We traded spaghetti code for what I like to call lasagna code. Still many layers, just neatly stacked, and sometimes even harder to navigate.
Lasagna Code, I love that. And that brings us right to the core of his argument, what he calls the interface tax. This idea that developers are conditioned to believe that you either ship fast and create garbage, or you do it right and pay this huge boilerplate tax. He argues that's a lie.
It's a massive lie. And the perfect example he gives is integrating something like Stripe. We all know the best practice, right? You need to abstract that third-party dependency. So you create an iPayment service, a Stripe payment service implementation, and then your process payment.handler injects the interface.
Exactly. You're following the rules, you're being architecturally responsible. But here's the kicker. For 99% of applications, you are never going to have another payment service. You have one implementation, and you've paid this tax for a scenario that will literally never happen.
And what is that tax? It's extra files, increased cognitive load, and the absolute worst offender, breaking IDE navigation. You hit Go to Definition, and it takes you to a useless interface that tells you absolutely nothing about the actual code that's running. You then have to hunt down the implementation, often diving into your DI container setup just to figure out what's going on. That's real, tangible friction for developers.
Oh, the go-to definition pain? You ever hit F12 on a method to see what it does, and Visual Studio drops you into an interface with zero implementation, and then you have to search the DI container to figure out what's actually running? That's the interface tax right there. It slows you down every single time you encounter it.
And the classic defense is always, but what if we switch from Stripe to PayPal? And as seasoned engineers, we know that's just a fantasy. Switching payment gateways is never as simple as swapping an iPayment service implementation. PayPal and Stripe have fundamentally different workflows, webhook structures, error handling, not to mention the domain logic changes. Your domain will have to change.
Absolutely. It's like saying we need to abstract our car's engine just in case we switch from gasoline to a jet engine. Sure, they both make the car go, but the interfaces, the fuel, the whole system is completely different. You're abstracting a problem you don't actually have.
And if the interface tax is a misdemeanor, then what they do to simple CRUD operations in the name of clean architecture, that's a felony.
Oh, tell me about it. The multi-layered mirage for a basic database update? I've seen it. Imagine you just need to update an order status from pending to fulfilled. In dogmatic clean architecture, that's 5 rigid layers you have to traverse.
5 layers. You start with the API controller receiving the HTTP request. Then it goes to a use case or application service to coordinate the workflow. Then a mapper maps the database entity to a domain model. The domain model finally has the fulfill method, which just flips a Boolean. And then a repository maps it back to a database entity and saves it. What are we even doing here?
It's like making a 7-layer dip just to eat a single tortilla chip. The amount of effort for such a simple operation is insane. Most of these layers are just passing data through. They're not adding any real business logic or protection.
9 times out of 10, they're just glorified data pipelines. And Comartin's pragmatic heresy, which makes enterprise architects gasp, is so refreshing. Just inject the ORM directly.
Oh, I can hear the gasps now. Inject the DB context directly into the request handler? The horror. But seriously, if there are no rich business invariants to protect, if it's just flipping a Boolean, why add all that ceremony? Find the record, update the status, save changes. Done.
Exactly. Entity Framework is a unit of work. It is a repository. When you write iRepository user, you're just putting a cheap plastic hubcap over a Ferrari. You're abstracting an abstraction that already exists and works perfectly well, and in doing so, you're stripping away all the powerful features of the underlying ORM. It's an architectural double tax.
You know, whenever you challenge clean architecture, the immediate reflexive defense is always, but how do I unit test it? Like, without interfaces, our code just becomes this untestable blob.
That's the testability shield, and it's fundamentally flawed. Developers have been brainwashed into believing that interfaces are the only way to test, but it's just not true anymore, if it ever was.
Right. Modern tools have come so far. Most third-party libraries provide fakes or alternate types for testing, and you can achieve isolation in much simpler ways, like just overriding a virtual method in a test class if you really need to.
And the industry is finally waking up to the fact that mocking an entire database layer just to unit test a CRUD operation is a monumental waste of time. It leads to brittle tests that verify how you wrote the code, not what it actually does. If your test file has 45 lines of mock.setup.returns, you aren't testing your code. You're testing your ability to write mocks.
It's so true. And then you change one thing in the implementation and half your tests break, even though the behavior of the system hasn't changed at all. That's a huge drag on velocity. Tools like test containers have made integration testing fast and reliable, letting you spin up a real ephemeral database for your tests. That makes excessive interface mocking completely obsolete for many scenarios.
Exactly. You're testing against something much closer to reality, which gives you more confidence. And this all ties into a deeper redefinition of coupling. We've been told that all coupling is evil.
Yeah, tight coupling is always the boogeyman.
But Comartin argues that coupling isn't inherently bad. Without coupling, you have nothing, he says. And he's right. Your code has to do something. The problem isn't coupling, it's uncontrolled coupling.
That's a profound distinction. So having one usage of a direct dependency, like the Stripe SDK or a DB context, in a specific feature handler is perfectly fine. The blast radius is contained to that single file.
Exactly. If that one file breaks, it's just that one file. But having 1,000 direct usages of a dependency scattered across your entire code base, that's dangerous. That's when an interface or an abstraction is actually required. The industry's mistake was applying the solution for a 1,000 usage problem to a 1 usage reality. We over-abstracted for the wrong problems.
So if clean architecture is actually slowing us down, what's the alternative? We can't just go back to spaghetti code, can we?
Absolutely not. The emerging consensus, championed by people like Jimmy Bogard and Comartin, is vertical slice architecture, or VSA, and it completely flips the way we organize our software.
Slicing the cake, right? I love that analogy. Clean architecture asks you to eat all the frosting, then all the sponge, then all the filling. VSA cuts you a whole slice from top to bottom.
Exactly. Traditional clean architecture separates code by technical concern, UI layer, business layer, data layer. VSA separates code by business capability or feature. So all the code required for a specific feature, the API route, the validation, the database query, the mapping, it all lives together, often in a single folder, sometimes even a single file.
That drastically reduces cognitive load. You're not jumping between 5 different projects or 10 different files to understand how a cancel order button works. Everything you need is right there.
It's high cohesion, load coupling at its best. And the real superpower of VSA is what they call heterogeneous architecture. Because slices don't couple to each other, they don't have to share the same architectural patterns.
Wait, so you're saying I could have one slice that's just a handler injecting a DB context for a simple CRUD operation, and another slice right next to it that's using a full-blown domain-driven design aggregate with rich invariants and domain events?
Precisely. You only pay the cost of complexity where the complexity actually exists. You don't force a one-size-fits-all architecture across the entire application. That's a huge win for pragmatism. It's not about being dogmatic. It's about using the right tool for the right job within a contained boundary.
This all sounds like a massive mindset shift, moving away from dogma. Komar 10 calls it the senior move.
He does. One of the most senior moves you can make is to stop following patterns blindly and start understanding the value they are supposed to provide. Then ask whether you actually need that value. Junior and mid-level engineers often hide behind best practices because it provides a defense mechanism in code reviews. But senior engineers recognize that best practices are highly contextual.
That's spot on. It's the difference between knowing the rules and knowing when to break them. And it ties into another controversial idea, embracing the dirty hack as long as its blast radius is contained.
This is liberating. In a vertically sliced system, if you ship a messy, procedural 300-line function that gets a critical feature out the door, and that code is isolated to a single vertical slice that no other feature depends on, that's a win. If it needs refactoring later, the refactoring is entirely localized. It doesn't handcuff future development of other features.
So it's not about never writing dirty code, it's about ensuring that if you do, it can't infect the rest of your system. You've contained the blast radius.
Exactly. It's pragmatic over pure. And let's not forget the AI imperative here, especially in 2026. Some developers argue that since AI coding assistants can generate boilerplate instantly, the interface tax no longer matters.
Yeah, so if you're new to keeping plants, try something like a snake plant or a ZZ plant. They're pretty easy to take care of.
But Comartin warns that's a dangerous trap. If AI makes producing code cheap, what else is going to be cheap? Creating a rat's nest turd pile of coupling. The bottleneck in software engineering isn't writing code anymore. It's reading and understanding code to make safe behavioral changes.
That's a crucial point. If AI generates thousands of lines of useless interfaces and mappers, the human engineer still has to read and maintain that cognitive load. AI might write it, but we still have to debug it at 2 a.m.
So pragmatic, cohesive design like vertical slices matters more in the age of AI, not less. It makes the human's job of understanding and maintaining the system actually feasible.
So to wrap this up, if there are 3 things listeners should really take away from this, what would they be?
First, that interface tax is absolutely real and it's expensive. Wrapping single-use dependencies in custom interfaces, like the Stripe SDK example, adds liability, breaks code navigation, and gives you an illusion of decoupling without actual flexibility.
Yeah, don't pay a tax for a problem you don't have. Second, multi-layered architecture is often massive overkill. Forcing simple database updates through all those layers, APIs, use cases, mappers, domain models, repositories, creates an illusion of clean code at the expense of productivity.
And third, coupling isn't inherently evil. It's unmanaged coupling that's the problem. The goal isn't to decouple everything, it's to isolate the blast radius of changes. Vertical slice architecture achieves this by managing coupling at the feature level, allowing teams to mix simple CRUD and complex DDD within the same application. It's about being smart, not dogmatic.
I think that's a mic drop moment. So for our listeners, how often have you fallen into the clean architecture trap, layering for the sake of layering? And what's one senior move you've made recently by not blindly following a pattern?
That's a wrap on this debug log. Join us next time for more engineering war stories and hard-won lessons. If any of this hit close to home, subscribe and tell your team.
Ship it carefully.